The German soldiers advancing through the Ardennes that December morning carried more than weapons. They carried certainty. Veterans of the Eastern Front moved with practiced efficiency through the snow-laden forest. They had survived Kursk, endured the grinding retreat through Ukraine, witnessed the collapse of Army Group Center. If they could withstand the Red Army's sledgehammer offensives, American forces seemed almost trivial by comparison. Obergefreiter Klaus Weber checked his Karabiner 98K as his squad prepared to move. The rifle felt familiar in his hands, identical to the one his father had carried at Verdun in 1916, virtually unchanged from the weapon his grandfather might have used in the Franco-Prussian War. The bolt moved smoothly, worn by countless repetitions. Lift, pull, push, lock. The walnut stock bore the scratches of 2 years on the Eastern Front. The weapon was reliable, accurate to 500 meters with iron sights, capable of killing at twice that distance in skilled hands. It had been enough in Poland, enough in France, enough barely in Russia. Weber's squad moved in tactical formation through the trees, their breath freezing in the pre-dawn darkness. Each man carried 60 rounds of 7.92mm ammunition, 5 stripper clips of 5 rounds each in pouches, plus 5 rounds loaded in the rifle's internal magazine, 60 rounds to last until resupply, which might be hours or days depending on how the offensive developed. The squad's MG-42 team moved at the center of the formation, 2 men carrying the machine gun, 3 more burdened with spare barrels and ammunition boxes. The MG-42 was the squad's primary weapon, capable of firing 1,200 rounds per minute, earning its nickname Hitler's Saw from the distinctive ripping sound it made. Everything else, the 8 riflemen, the squad leader, existed to support that machine gun, to keep it fed, protected, and firing. This doctrine had proven devastatingly effective for 5 years. At proper defensive positions, with the MG-42 providing suppressive fire, German squads had held against numerically superior forces across Europe and Russia. The riflemen provided security, engaged targets beyond machine gun range, and maintained defensive sectors when the MG-42 repositioned. But doctrine assumed certain constants. It assumed enemies armed similarly, with bolt-action rifles requiring manual cycling. It assumed engagement ranges where marksmanship mattered more than fire rate. It assumed the tactical reality that had governed infantry combat since smokeless powder replaced black powder in the 1890s. Riflemen fired aimed shots at deliberate pace, working their bolts between rounds, making each cartridge count. The Americans, Weber had been told during the pre-offensive briefing, were poorly trained and over-reliant on artillery and air support. Without those advantages, and the weather had grounded Allied aircraft, they would collapse quickly under determined assault. German discipline and combat experience would prevail as it always had. Before we continue, click that subscribe button, like this video, and let me know in the comments where you're watching from. It brings me great joy knowing that these war stories and lessons get to people all over the world. Your support helps us bring more thrilling war stories, and trust me, you won't want to miss them. Now let's get back to the story. Weber advanced through the snow, his K98K at the ready, confidence built on 5 years of victories and survival. The weight of the rifle in his hands felt like certainty itself. Within the hour, that certainty would shatter with the first burst of semi-automatic fire. The Karabiner 98 Kurds represented the pinnacle of 19th-century small arms design, perfected into the 20th century. Adopted in 1935, it was essentially a shortened version of the Gewehr 98 that had armed Imperial German forces in World War I. The modifications were minimal: a turned-down bolt handle for easier carrying, a shorter barrel for improved handling, refined sights. The operating system remained unchanged from Paul Mauser's 1898 design. This consistency was considered of virtue. German military philosophy valued precision engineering and proven reliability over experimental innovation. The K98K was beautifully crafted, machined steel components, fitted by skilled armorers, walnut stocks hand-selected for grain quality, barrels that could maintain accuracy through thousands of rounds. Each rifle represented approximately 75 hours of skilled labor to manufacture. But beauty and craftsmanship could not overcome mechanical limitations. Every shot demanded the same four-step manual sequence. After firing, the soldier grasped the bolt handle, a knob of machined steel protruding from the right side of the receiver. Lift upward, rotating the bolt to unlock the lugs. Pull rearward, extracting the spent cartridge and ejecting it. Push forward, stripping a fresh round from the internal magazine and chambering it. Press down and forward, rotating the bolt to lock the lugs. Only then could the rifle fire again. Under ideal conditions, a soldier lying prone on a rifle range with no incoming fire, no adrenaline flooding his system, no need to observe his target or seek cover. An expert marksman might achieve 15 aimed rounds per minute. Combat reality reduced this dramatically. A soldier advancing under fire, breathing hard, hands shaking with adrenaline, struggling with cold or fatigue, typically managed 8 to 10 aimed shots per minute at best. The internal magazine held 5 rounds loaded via stripper clips, metal guides that allowed cartridges to be pushed down into the magazine in a single motion. Reloading required the soldier to reach into his ammunition pouch, retrieve a stripper clip, position it over the magazine opening, press down firmly to strip the rounds into the magazine, then discard the empty clip. Under combat stress, this process consumed 8 to 10 seconds minimum. The mathematical result? A German rifleman firing continuously could deliver approximately 40 to 50 rounds in the first 5 minutes of engagement, assuming he carried enough loaded stripper clips for rapid access. After that, as he fumbled for clips in pouches, fire rate declined further. These limitations mattered little at the engagement ranges that dominated early 20th century warfare. In the open terrain of Poland and France, where battles unfolded at 300 to 500 meters, aimed fire and marksmanship determined outcomes. The K98K excelled in these conditions, accurate, reliable, lethal at distance. But modern warfare had evolved beyond open fields. The hedgerows of Normandy created killing zones at 50 meters. Italian mountains forced engagements at pistol range around rocky outcroppings. The forests of Belgium and Germany offered concealment at distances where a soldier could see the whites of enemy eyes. In these environments, close, chaotic, fast-moving, the careful aimed shot became irrelevant. What mattered was the ability to deliver rapid, sustained fire while advancing or defending. What mattered was keeping an enemy's head down long enough to maneuver. What mattered was volume of fire, overwhelming precision. The K98K, for all its craftsmanship and proven reliability, was designed for a war that no longer existed. In January 1936, the United States Army adopted a weapon that would fundamentally alter infantry combat: the U.S. rifle caliber .30 M1. Designed by Canadian-born engineer John C. Garand at Springfield Armory, it became the world's first semi-automatic rifle issued as standard equipment to an entire military force. The designation semi-automatic carried profound tactical implications. Unlike bolt-action rifles requiring manual cycling between shots, the M1 Garand harnessed the physics of firing itself to operate the weapon. When a cartridge detonated, expanding gases drove the bullet down the barrel. A small port near the muzzle diverted a portion of those gases into a cylinder beneath the barrel, driving a piston rearward. This piston operated a rotating bolt that extracted the spent cartridge, ejected it, cocked the hammer, and chambered a fresh round from the internal magazine, all in a fraction of a second. The soldier simply pulled the trigger. The rifle did everything else. This system allowed a rifleman to fire 8 rounds as rapidly as he could pull the trigger and reacquire his target, typically 2 to 3 seconds for all 8 rounds. An average infantryman could deliver 40 to 50 aimed shots per minute, 3 times the rate of even expert bolt-action riflemen. Under sustained fire conditions, that advantage became overwhelming. The M1's feeding system was equally revolutionary. 8 rounds loaded into an en-bloc clip, a thin metal frame that held cartridges in a single unit. The entire clip inserted into the rifle from the top, pushed down until it locked into place with a distinctive metallic click. When the 8th round fired, the empty clip ejected automatically with a sharp ping, and the rifle was ready for immediate reloading. An experienced soldier could reload in under 3 seconds without removing the weapon from his shoulder or losing sight of his target. The rifle weighed 9.5 pounds empty, slightly heavier than the K98K's 8.6 pounds, but distributed that weight in ways that reduced felt recoil and maintained balance during rapid fire. The gas-operated system absorbed much of the recoil energy, making the rifle remarkably controllable even during rapid shooting. The semi-automatic action was forgiving. A nervous or fatigued soldier could still deliver effective fire without the precise manual manipulation required by bolt actions. Accuracy matched any bolt-action rifle in service. Effective range extended to 500 yards with iron sights, with lethal capability well beyond. The .30-06 Springfield cartridge it fired was powerful enough to penetrate light cover and remained effective at ranges where most combat actually occurred, inside 300 yards. But the M1's most revolutionary aspect wasn't mechanical, it was philosophical. Every American infantryman carried this weapon. Not just specialists, not just NCOs, not elite troops receiving special equipment. Every single rifleman in every rifle squad in every infantry division carried the same semi-automatic firepower. Where German doctrine concentrated firepower in the MG-42 and treated riflemen as supporting elements, American doctrine distributed overwhelming firepower across the entire squad. An American rifle squad wasn't built around one automatic weapon. It was composed of 11 semi-automatic rifles, each capable of sustained rapid fire, supported by a Browning automatic rifle and a light machine gun. General George S. Patton recognized what this meant. In his January 26, 1945 letter to Major General Levin H. Campbell, Chief of Ordnance, he wrote, "In my opinion, the M1 rifle is the greatest battle implement ever devised." He was not exaggerating. The M1 Garand had made every American infantryman a force multiplier. February 1943, Kesselring Pass, Tunisia. German forces under Generaloberst Hans-Jürgen von Arnim launched a coordinated assault against American positions in the Atlas Mountains. The attack initially succeeded. Inexperienced American units broke under the assault, falling back in disorder. German tankers and infantry veterans, fresh from years of desert warfare against the British Eighth Army, pressed their advantage with professional efficiency. Then came the counterattack at Thala and the defensive stands that followed. And German after-action reports began documenting something unexpected. Hauptmann Friedrich Vollmer, commanding a company of the 10th Panzer Division, filed a combat report on February 24th describing an engagement near Spiba. His infantry had advanced against what reconnaissance identified as a reinforced American platoon holding a ridgeline. Standard tactics applied. MG-42 teams established suppressive fire, while rifle squads maneuvered to flanking positions. But the volume of return fire didn't match the estimated enemy strength. Vollmer's report noted, enemy rifle fire maintained continuous volume, inconsistent with observed force size. Estimated enemy possessed automatic weapons in every position. Casualties during approach phase exceeded projections by factor of 2. Similar reports filtered back from multiple engagements across Tunisia. German officers described American positions generating rifle fire that seemed to come from machine gun emplacements. Flanking maneuvers that should have caught riflemen reloading instead encountered sustained fire throughout the approach. American squads, pinned down by MG-42 fire, somehow maintained suppressive fire of their own, something impossible if they were armed with bolt-action rifles. Oberst Klaus von Bonin, intelligence officer for the 5th Panzer Army, compiled these reports into a memorandum submitted to Wehrmacht High Command in early March 1943. The document, captured after the North African campaign and now preserved in the U.S. National Archives, stated, "Multiple combat engagements indicate American infantry units equipped with semi-automatic rifles as standard issue, not limited to specialist or NCO allocation. This represents significant tactical advantage in fire rate and sustained fire capability." The response from Berlin revealed a fundamental failure of imagination. Wehrmacht analysts dismissed the reports as battlefield confusion. American forces, they noted, possessed Thompson submachine guns, Browning automatic rifles, and captured German automatic weapons. Officers under combat stress, the analysts suggested, were likely misidentifying these weapons or overestimating their prevalence. The memorandum response, dated March 18, 1943, concluded, "Semi-automatic rifles in quantities described would require industrial capacity and production sophistication beyond documented American capabilities. Reports likely reflect tactical surprise from concentrated automatic weapons, not widespread semi-automatic rifle distribution." The analysts based this conclusion on German production realities. Their own semi-automatic rifle programs, the G41 and its successor, the G43, faced constant manufacturing difficulties. Tolerances were tight, parts required hand-fitting, production rates remained experimental. If German industry, with its vaunted engineering precision and experienced craftsmen, couldn't mass-produce semi-automatic rifles, how could the Americans? This assumption that American industrial methods were inferior to German engineering would prove one of the war's most catastrophic intelligence failures. By the time of von Bonin's report, Springfield Armory alone was producing over 3,000 M1 Garands per day. Winchester Repeating Arms was adding another 1,000 daily. International Harvester's production lines were coming online. American factories were manufacturing semi-automatic rifles faster than Germany could produce bolt-actions. The reports from Tunisia weren't exaggerated. If anything, they understated the firepower disparity American forces would bring to Europe. German intelligence had seen the future and declared it impossible. That decision would cost them dearly in the battles to come. September 1943, the Apennine Mountains. German forces established defensive positions across Italy's mountainous spine, turning ancient hilltop towns into fortresses and steep valleys into killing zones. The terrain seemed to favor defenders, narrow approaches, limited fields of fire, positions that could be held by small units against larger attacking forces. General Major Eberhard Roth, commanding the 26th Panzer Division, understood mountain warfare. Defenders on high ground with bolt-action rifles could dominate approaches. The mathematics of elevation favored marksmanship over fire rate. A soldier firing downward at exposed attackers climbing steep terrain needed accuracy, not rapid fire. Those calculations proved obsolete against American infantry. At Monte Cassino, along the Gustav Line, and in dozens of smaller engagements across the Italian peaks, German defenders discovered that American squads advancing uphill could generate suppressive fire that made return fire nearly suicidal. Where German riflemen had to expose themselves to work their bolts, lifting their heads above cover, using both hands to cycle the action, American riflemen could maintain continuous fire from covered positions, their M1 Garands requiring only trigger pulls. A captured German tactical report from the 1st Parachute Division, dated November 1943, described an engagement near San Pietro Infine. Enemy squad estimated at 12 men generated fire volume equivalent to our platoon strength position of 40 men. Sustained fire prevented effective return fire or repositioning. Our MG-42 teams targeted immediately due to distinctive sound, but enemy rifle fire continued without reduction. The terrain that should have neutralized American firepower advantages instead amplified them. In mountains, engagement ranges compressed. Battles that might unfold at 400 meters on open ground occurred at 75 to 100 meters across rocky ravines. At these distances, the careful aimed shots of bolt-action rifles lost their advantage. What mattered was putting rounds downrange continuously, forcing defenders to keep their heads down while other elements maneuvered. American infantry tactics evolved to exploit this advantage. Rifle squads could conduct marching fire assaults up steep terrain, advancing in bounds while maintaining continuous fire. Half the squad moved while the other half fired, then roles reversed. With M1 Garands, the covering element could generate enough fire to genuinely suppress defenders rather than merely threaten them. Lieutenant Hans Weber, a platoon commander in the 3rd Panzergrenadier Division, kept a personal journal later captured near Anzio. His December 14, 1943 entry noted, "The Americans attack differently than the British or French. Their riflemen advance while firing continuously. Our doctrine assumes attackers must pause to reload, creating opportunity for counterfire. This assumption no longer holds. When American squads attack, we face fire equivalent to multiple machine gun positions. Casualties mount even when we hold numerical advantage in defensive positions." The firepower disparity became impossible to ignore. German squad leaders watching American attacks described seeing muzzle flashes from every attacking rifleman simultaneously, something mechanically impossible with bolt-action rifles. The distinctive 8-round bursts of M1 fire, followed by the metallic ping of ejecting en-bloc clips, then immediate resumption of fire, created a psychological effect beyond the physical danger. German soldiers began calling American rifle squads Maschinengewehr Infanterie, machine gun infantry. It wasn't accurate technically, but it captured the tactical reality. Every American rifleman fought with firepower that German doctrine reserved for specialists. In Italy's mountains, where terrain should have equalized combat, American industrial firepower was rewriting the rules of infantry warfare. June 6, 1944. Omaha Beach. The 352nd Infantry Division occupied positions overlooking the landing zones, protected by concrete fortifications and interlocking fields of fire. German defenders initially inflicted devastating casualties on the landing forces, turning sections of the beach into killing grounds exactly as coastal defense doctrine intended. Yet within hours, American infantry had breached the defenses and pushed inland. German after-action reports documented the assault with professional precision and growing concern about the volume of American small arms fire. One report from Widerstand's Nest 62, a strongpoint overlooking Easy Red sector, noted, "Enemy infantry maintains continuous rifle fire while advancing. No pause for bolt manipulation observed." Fire volume exceeds expectations for unit size. But Normandy's beaches were merely the opening engagement. The real revelation came in the bocage, the hedgerow country of inland Normandy. The Norman hedgerows were ancient earthen berms topped with dense vegetation, creating a maze of small fields connected by sunken lanes. Each hedgerow provided natural fortification. Each field became a separate battlefield. Engagement ranges rarely exceeded 100 meters, often compressing to 30 or 40 meters in the narrow lanes. Visibility was limited. Maneuver was constrained. Combat became a brutal sequence of close-quarter firefights. This terrain should have neutralized American material advantages. Tanks couldn't navigate the narrow passages. Artillery couldn't see targets. Air support couldn't distinguish friend from enemy in the dense vegetation. Infantry would decide the bocage battles, and infantry combat, German doctrine assumed, favored experienced soldiers with proven weapons. Instead, the hedgerows became a nightmare for German defenders. At 50 meters, the theoretical advantages of the K98K, accuracy, range, careful marksmanship, became irrelevant. What mattered was seeing an enemy first and getting rounds downrange immediately. The soldier who could fire 8 times in 3 seconds overwhelmed the soldier who could fire twice while working his bolt. A German tactical assessment from the 17th SS Panzer Grenadier Division, dated July 3, 1944, described the reality. Enemy rifle squads generate fire equivalent to our machine gun positions. In close terrain, American infantry advances with continuous covering fire from all squad members. Conventional suppression tactics prove ineffective. Our riflemen cannot achieve fire superiority against enemy equipped with semi-automatic weapons. The document continued with stark admission. Current infantry manual calculations for assault and defense assume bolt-action rifles for all forces. These calculations no longer reflect tactical reality. An American squad of 12 men delivers fire rate of German platoon of 40 men. Numerical superiority required to achieve fire parity now estimated at 3.1 minimum. German infantry manuals, refined through 2 world wars, codifying hard-won tactical lessons, became obsolete in a matter of weeks. The fundamental mathematics of fire and movement no longer worked. Doctrine assumed defenders could return aimed fire during attacker reload cycles. The Americans had no reload cycles. Doctrine assumed suppressive fire required machine guns or concentrated rifle volleys. The Americans delivered suppressive fire from every rifleman. Oberst Rudolf von Gersdorff, Chief of Staff for the 7th Army in Normandy, filed multiple reports to Wehrmacht High Command requesting immediate production and distribution of semi-automatic rifles. His July 15th memorandum was blunt. American firepower superiority at squad level represents fundamental tactical disadvantage that cannot be overcome through training or tactical adjustment. Material solution required urgently. But material solutions required time Germany no longer possessed. The G43 semi-automatic rifle remained in limited production, allocated primarily to snipers and specialist troops. Even if production could be increased, German industry lacked the manufacturing capacity to re-equip millions of soldiers while simultaneously producing tanks, aircraft, and ammunition under constant Allied bombing. In Normandy's hedgerows, German soldiers fought with weapons from 1898 against an enemy armed with the future. The M1 Garand's tactical superiority began not on battlefields, but in American factories, facilities that achieved manufacturing scales and precision German industry could not match, despite years of total war mobilization. Springfield Armory in Massachusetts served as the primary production facility and quality standard for all M1 manufacturing. The main production building stretched over a mile in length, housing specialized machinery that performed over 1,000 distinct operations in transforming raw steel and walnut into finished rifles. By 1943, Springfield Armory employed 13,000 workers operating around the clock in 3 shifts. The workforce itself represented American mobilization's unique character. By June 1943, women comprised 43% of Springfield's workers, 5,210 women among 12,000 total employees. Many had no prior manufacturing experience before the war. They operated precision machinery, performed complex quality inspections, and assembled components to tolerances measured in thousandths of an inch. Within weeks of training, they were producing weapons that exceeded German quality standards. Production efficiency improved dramatically as experience accumulated. In 1940, manufacturing a single M1 Garand required 117 man-hours of labor. By 1943, this dropped to 75 man-hours. By 1945, Springfield Armory completed rifles with just 31 man-hours, a 74% reduction from the war's beginning. Per-unit cost fell from $83 in 1940 to $31 by 1945. Springfield reached peak production in January 1944, 122,001 rifles that month, 3,936 per day, 164 rifles every hour of continuous production. This single facility, in 1 month, produced nearly 3 times the total number of G43 semi-automatic rifles Germany manufactures during the entire war. But Springfield was merely the largest producer. Winchester Repeating Arms Company, leveraging its commercial firearms expertise, manufactured 513,080 M1 Garands. International Harvester, traditionally a manufacturer of farming equipment, successfully converted production lines to military use, producing 337,623 rifles. Harrington and Richardson would add 428,600 rifles during and after the war. This distributed production meant no single bombing raid could cripple American rifle manufacturing. Germany's concentrated war industries, despite extensive dispersal efforts, remained vulnerable to strategic bombing. American production spread across multiple states, multiple companies, multiple facility types, all producing interchangeable components to identical specifications. The interchangeability itself represented a manufacturing achievement German craftsmen could not replicate. A trigger assembly from a Springfield rifle fit perfectly into a Winchester receiver. A bolt from an International Harvester rifle functioned identically in a Harrington and Richardson action. Every component from every manufacturer met the same tolerances, requiring no hand-fitting or individual adjustment. German ordnance officers who examined captured M1 Garands were astounded by this precision achieved at massive scale. A Wehrmacht technical intelligence report from August 1944 stated, "The M1 rifle demonstrates mass production techniques we cannot replicate. Components show precise tolerances maintained across thousands of examples. Interchangeability of parts is complete. Any component from one rifle functions perfectly in another. This level of standardization at this production volume exceeds German industrial capacity." The practical battlefield advantage was enormous. And American armorers could repair damaged rifles in minutes using parts from any other M1, regardless of manufacturer. A broken extractor, a damaged firing pin, a worn recoil spring, all could be replaced instantly with components carried in unit supply. German K98K rifles, with their hand-fitted parts and craftsman assembly, required skilled armorers and specific components for each manufacturer's variation. By war's end, American factories had produced 5,468,772 M1 Garand rifles. This industrial achievement, combining unprecedented scale with extraordinary precision, represented a manufacturing philosophy fundamentally different from German approaches. Where German industry emphasized craftsmanship and individual quality, American industry achieved quality through standardization and statistical process control. Where German production relied on skilled workers hand-fitting components, American production used specialized machinery operated by rapidly trained workers producing identical parts. The result? Every American infantry division landed with thousands of semi-automatic rifles, with supply chains ensuring immediate replacement of damaged weapons and unlimited spare parts. Germany's industrial tradition, for all its engineering excellence, could not match American industrial democracy's scale. German ordnance officials recognized the semi-automatic rifle problem years before the war began. As early as 1940, the Wehrmacht initiated development programs for self-loading rifles to match emerging threats. What followed was a case study in how industrial limitations and engineering philosophy could defeat tactical necessity. The Gewehr 41, introduced in 1941, represented Germany's first serious attempt at a standard-issue semi-automatic rifle. Two designs competed, one from Mauser, one from Walter. Both failed spectacularly in field testing. The gas systems proved unreliable. Accuracy was inconsistent. Weight exceeded acceptable limits. Complexity made field maintenance nearly impossible for average soldiers. Production remained experimental, with only 145,000 combined units manufactured before the program was abandoned. The Gewehr 43, introduced in 1943, incorporated lessons from the G41's failures and borrowed heavily from the Soviet SVT-40 design. The G43 was genuinely effective, accurate, reasonably reliable, and capable of the sustained fire that German infantry desperately needed. In the hands of trained soldiers, it performed admirably. But German industry could not produce it in meaningful quantities. The fundamental problem was manufacturing philosophy. German weapons production emphasized precision craftsmanship. Components were machined to tight tolerances, then hand-fitted by skilled armorers to ensure perfect function. Each rifle was essentially a custom piece, adjusted and refined by experienced workers. This approach produced weapons of exceptional quality, when time and resources permitted. War production operated under different constraints. The G43 required extensive machining of complex parts. The gas system demanded precise tolerances to function reliably. The detachable magazine system, necessary for rapid reloading, required additional manufacturing steps. Each rifle consumed approximately 80 hours of skilled labor to complete, nearly 3 times the American M1's production time by 1944. Worse, components were not truly interchangeable. A G43 bolt from one rifle might require fitting to function properly in another. Extractors needed individual adjustment. Gas systems required tuning. This meant battlefield repairs demanded skilled armorers rather than simple parts replacement. It meant spare parts couldn't be stockpiled as generic inventory, but had to be matched to specific weapons. Total verified G43 production across all manufacturers: 402,713 rifles throughout the entire war. By comparison, Springfield Armory alone produced more than 4 million M1 Garands during the same period, nearly 10 times German total production from a single American facility. The allocation priority revealed the scarcity. Where every American infantryman carried an M1 Garand as standard issue, the G43 was reserved for specialist troops. Snipers received them first, fitted with telescopic sights. Veteran NCOs and squad leaders might receive them. Elite units like Fallschirmjäger and Waffen-SS divisions had higher allocation rates. Regular Wehrmacht infantry divisions often possessed only a handful per company. A German infantry company in late 1944 might field 150 soldiers, and perhaps 10 to 15 semi-automatic rifles among them. An equivalent American rifle company fielded 190 soldiers, equipped with approximately 140 M1 Garands as standard infantry weapons. Wehrmacht training materials acknowledged the disparity with stark pragmatism. A tactical manual addendum from October 1944 instructed, when engaging American infantry, assume enemy possesses 3-to-1 fire rate advantage at squad level. Achieve local numerical superiority of 3.1 minimum before initiating assault. Maximize use of machine gun fires. Avoid prolonged rifle exchanges. The guidance essentially admitted German riflemen could not win firefights against American riflemen. Doctrine must compensate for material inferiority. German engineers understood semi-automatic rifle technology. German soldiers desperately needed semi-automatic rifles. But German industry, for all its vaunted precision and engineering excellence, could not manufacture them in the quantities warfare demanded. The gap between tactical requirement and industrial capacity would prove unbridgeable. By the time G-43 production reached even modest levels, millions of American soldiers already carried M1 Garands, and the outcome of the war was no longer in doubt. December 16, 1944. The German offensive crashed into American positions with overwhelming force. Hitler had assembled 200,000 men, 600 tanks, and 1,900 artillery pieces for Operation Wacht am Rhein, the last major offensive the Wehrmacht could mount. Initial attacks achieved complete tactical surprise. American units, many inexperienced or recovering from earlier battles, found themselves surrounded, outnumbered, and fighting for survival. The mathematics favored the Germans. In multiple sectors, they achieved 3-to-1 or greater numerical superiority. Standard military doctrine since Napoleon held that attackers needed 3-to-1 advantages to overcome prepared defenses. The Germans possessed that advantage and more. By traditional calculations, American positions should have collapsed within hours. Instead, small American units held. At Elsenborn Ridge, the 99th Infantry Division, a unit that had seen minimal combat, faced assault from the 12th SS Panzer Division and elements of the 277th Volksgrenadier Division. The Germans attacked with veteran troops, combined arms coordination, and local superiority exceeding 3-to-1 in infantry strength. They advanced into a wall of rifle fire unlike anything their tactical manuals predicted. U.S. Army combat interviews conducted immediately after the battle preserved the experience. Staff Sergeant Vernon McGarity, 99th Infantry Division, described the engagement. "We just kept firing. 8 rounds, reload, 8 more. The Germans tried to rush us 3, 4 times. They couldn't get through the fire. Bodies were stacking up 50 yards out." Private First Class Richard McKee, same unit, recalled, "The sound was continuous, everyone firing as fast as they could pull triggers, the ping of empty clips ejecting, then right back to firing. I went through 80 rounds in maybe 10 minutes. We all did." The firepower density was staggering. An American rifle squad with 11 M1 Garands could theoretically deliver 440 rounds per minute of sustained aimed fire, more than most machine gun positions. A platoon with 3 squads generated fire equivalent to a German company. American soldiers, trained to advance with marching fire, applied the same doctrine to defense, continuous fire preventing enemy movement. German casualties in the first 3 days of the offensive exceeded all planning projections. Units that should have broken through in hours instead spent days attempting to advance through American defensive fire. A captured operations order from the 12th SS Panzer Division, dated December 18th, provided stark tactical revision. American small arms fire prevents infantry movement even with numerical superiority. Each enemy position must be treated as automatic weapon emplacement. Advance only with armored support. At Bastogne, the 101st Airborne Division and attached units, surrounded and outnumbered, held the critical road junction for 7 days. German forces possessed every advantage: numbers, artillery, armor. What they couldn't overcome was the sustained rifle fire from defenders who never had to pause to work bolts, who reloaded in 3 seconds, who could maintain suppressive fire continuously. Oberst Friedrich August Freiherr von der Hayete, commanding Fallschirmjäger forces near Monschau, filed a combat assessment on December 20th that captured German frustration. Enemy defensive fire volume exceeds capacity of attacking forces to suppress. Standard assault tactics predicated on fire superiority during approach. This superiority cannot be achieved against enemy rifle-equipped forces. Casualties prohibitive. The traditional arithmetic of warfare that 3 attackers could overwhelm 1 defender had been rewritten. When that 1 defender possessed 3 times the fire rate, the equation balanced. When every defender in a position maintained semi-automatic fire, numerical advantage became insufficient. The Battle of the Bulge demonstrated what German commanders had feared since North Africa. American infantry could not be defeated through conventional tactics when armed with M1 Garands. Fire superiority, the foundation of infantry assault doctrine, belonged to the Americans regardless of numbers. Hitler's final offensive failed for many reasons: fuel shortages, weather, logistics. But at the tactical level, at the point where infantry met infantry, German soldiers discovered they simply could not advance through the volume of fire American riflemen generated. The firepower wall held. January 1945. Temperatures in the Ardennes plunged to the coldest levels recorded in decades. Nighttime lows reached 20 degrees. Daytime temperatures rarely climbed above freezing. Snow accumulated in drifts that buried foxholes and obscured landmarks. These conditions, miserable for all soldiers, created specific mechanical challenges that favored semi-automatic weapons over bolt actions in ways no tactical manual anticipated. Cold weather has always been the enemy of mechanical systems. Metal contracts. Lubricants thicken into sludge. Moisture freezes in microscopic gaps. For bolt-action rifles, these effects compounded into cascading failures. The Carabiner 98K required manual operation of its bolt mechanism, a system of rotating lugs, extractors, ejectors, and springs that demanded smooth mechanical action. In extreme cold, the thin film of oil German soldiers applied to prevent rust became viscous, adding resistance to every movement. Soldiers attempting to work frozen bolts had to grip the bolt handle with both hands, sometimes striking it with their palms to break the action free. Worse, the manual cycling exposed the rifle's internal mechanisms to the elements with every shot. Opening the bolt allowed snow and ice to enter the receiver. Moisture from breath condensed on cold metal and froze instantly. After several shots, ice could accumulate in the bolt raceway, making the action progressively stiffer until it froze completely solid. German soldiers learned to fire slowly in extreme cold, allowing time to carefully work each bolt cycle. They learned to cup their hands around the action to protect it from snow. They learned to strip oil from mechanisms entirely, accepting increased wear in exchange for continued function. Despite these adaptations, K98K rifles regularly failed in sustained firefights, their bolts frozen or jammed with ice. Frontline reports documented the problem. A medical company log from the 26th Volksgrenadier Division noted an unusual casualty pattern. Multiple injuries to hands and fingers attributed to soldiers striking frozen rifle bolts. Recommend review of cold weather weapon maintenance procedures. The M1 Garand operated under the same brutal conditions, but its semi-automatic action transformed cold weather from crippling disadvantage to marginal inconvenience. The gas-operated system remained sealed during firing. The bolts cycled automatically, driven by gas pressure rather than manual manipulation. Ice could form on external surfaces, but the critical internal mechanisms remained protected. The rifle's self-loading action meant soldiers rarely exposed the receiver to freezing air. More importantly, the M1 required minimal manual manipulation. Soldiers could fire while wearing heavy winter gloves. The trigger remained accessible, and no bolt handle needed grasping. Reloading demanded only gross motor skills. Press the en-bloc clip down into the magazine. Even with numb fingers and bulky gloves, soldiers could reload in seconds. American doctrine adapted quickly. Field manuals issued in December 1944 provided updated guidance. Maintain rifles without oil in extreme cold. Cycle the action several times before combat to verify function. Carry ammunition inside uniforms to prevent freezing. With these simple procedures, M1 Garands continued functioning in conditions that rendered bolt actions marginal. The tactical advantage was profound. German soldiers struggling with frozen bolts couldn't maintain fire rates. They couldn't work their actions with gloved hands. They faced agonizing choices: remove gloves for weapon manipulation and risk frostbite, or keep gloves on and struggle with frozen mechanisms. American soldiers faced no such dilemma. They maintained suppressive fire in sub-zero temperatures, their semi-automatic rifles cycling smoothly while German return fire stuttered and died. U.S. Army medical records from the Battle of the Bulge documented significantly lower frostbite casualties among American riflemen compared to German prisoners, partly attributed to reduced exposure during reloading sequences. American soldiers kept their hands protected while maintaining fire. German soldiers repeatedly exposed bare hands to manipulate frozen bolts. January 1945. Offensive operations saw American forces maintain momentum despite brutal cold. The 1st Infantry Division advanced across frozen ground, their rifle squads generating continuous fire. German defenders, their K98A bolts sluggish or frozen, couldn't generate return fire sufficient to halt the advance. Weather that should have frozen the battlefield into stalemate instead amplified American firepower advantages. The M1 Garand proved not just superior in firepower, but superior in the environmental extremes where wars were actually fought. March 1945. As American forces prepared to cross the Rhine, the final geographic barrier protecting Germany's industrial heartland, Wehrmacht planners faced mathematical realities no amount of courage or tactical skill could overcome. Generalleutnant Fritz Bayerlein, commanding the WWII Army Corps defending the Rhine's west bank, received a planning directive from Army Group B requiring defensive calculations based on traditional force ratios. German military doctrine, refined through 150 years of European warfare, assumed one defender in prepared positions could engage 3 attackers effectively. This calculation underpinned every defensive plan from Frederick the Great through both World Wars. Bayerlein's staff attempted to apply these formulas to current conditions. The results were impossible. A captured German planning document from the WWII Corps headquarters, dated March 7, 1945, reveals the problem in stark detail. Defensive calculations assume equivalent weapon systems and training. American rifle superiority estimated at 3:1 fire rate advantage renders traditional ratios invalid. To achieve fire parity with attacking American Rifle Company, 140 semi-automatic rifles, defending force requires 420 bolt-action rifles, equivalent to battalion strength. The document continued with brutal clarity. Current troop availability insufficient to achieve required force ratios. American firepower superiority cannot be countered with available resources. The mathematics were undeniable. An American rifle squad with 11 M1 Garands could deliver approximately 440 aimed rounds per minute sustained fire. A German rifle squad with 8 K98K rifles could deliver perhaps 120 rounds per minute. The ratio wasn't 3.1, it was nearly 4:1 in favor of the Americans. At platoon level, the disparity multiplied. An American rifle platoon with 3 squads generated fire equivalent to a German company. An American rifle company produced firepower matching a German battalion. These weren't theoretical calculations. They reflected observed combat performance across Italy, France, and Belgium. German tactical doctrine had evolved around achieving fire superiority during the assault phase. Infantry advanced while machine gun teams provided suppressive fire, forcing defenders to keep their heads down. Once assault elements closed to grenade range, defenders couldn't maintain effective fire, allowing final assault. This doctrine assumed defenders armed with bolt-action rifles who needed to expose themselves to work their actions. Against M1-equipped Americans, the doctrine collapsed. American defenders maintained continuous fire from covered positions. German assault elements took casualties throughout their approach. Machine gun teams were targeted immediately. The final assault phase arrived, if it arrived at all, with attacking forces already depleted and disorganized. A Wehrmacht training circular distributed in February 1945 acknowledged the crisis. American defensive positions cannot be suppressed by conventional means. Fire superiority during approach phase cannot be achieved without 3.1 numerical advantage in attacking force. Battalion strength attacks required to overcome company strength American positions. But Germany no longer possessed battalion strength reserves for every company-sized American position. The Wehrmacht of March 1945 was a shell of the force that had conquered Europe in 1940. Units existed on paper at full strength, but fielded 40–50% of authorized personnel. Replacements were teenagers and older men with minimal training. Weapons were worn, ammunition scarce, fuel for vehicles nearly non-existent. The Rhine crossings demonstrated the arithmetic of defeat in action. At Remagen, where the Ludendorff Bridge was captured intact, on March 7th, German counterattacks failed despite American bridgehead forces being outnumbered initially. Small American units generated sufficient firepower to hold positions until reinforcements arrived. At Oppenheim, where Patton's Third Army crossed on March 22nd, German defenders couldn't prevent establishment of bridgeheads despite occupying prepared positions. American rifle fire suppressed defensive positions more effectively than German artillery could suppress attackers. Oberst Gunther Reichhelm, operations officer for Army Group B, wrote in his post-war memoir, "By March 1945, our infantry could not contest American infantry in direct engagement. The firepower disparity was insurmountable. Every tactical calculation demonstrated the impossibility of our situation. We fought because orders demanded it, not because victory was achievable." The M1 Garand hadn't just provided Americans with superior firepower, it had invalidated the mathematical foundations of German defensive doctrine. When every equation resulted in impossible numbers, defeat became not a possibility, but a certainty. The Rhine crossing succeeded not just through Allied material superiority in tanks and aircraft, but through the accumulated advantage of millions of American riflemen, each carrying 3 times the firepower of their German counterparts. The arithmetic was absolute, and Germany had lost. The war ended in May 1945. In the years that followed, as historians and military analysts examined what had determined outcomes on the battlefield, a consensus emerged among former German commanders. The M1 Garand represented one of the most significant tactical advantages the Allies possessed. General Major Friedrich von Mellenthin, who served as a senior staff officer throughout the war, wrote in his 1956 memoir, Panzer Battles, "The American semi-automatic rifle was a weapon of extraordinary effectiveness. In combat, particularly at close range, it provided an advantage we could never overcome. Our soldiers, armed with bolt-action rifles, simply could not match the volume of fire American infantry generated." General der Panzertruppe Hasso von Manteuffel, commander of the 5th Panzer Army during the Battle of the Bulge, was even more direct in post-war interviews. The superiority of American infantry firepower was decisive in many engagements. Our tactical doctrine assumed certain capabilities from our riflemen that proved inadequate against an enemy where every man possessed what amounted to automatic fire capability. These assessments, from officers who had commanded at the highest levels, acknowledged what frontline soldiers had experienced directly. The bolt-action rifle era had ended. The future of infantry combat belonged to self-loading weapons that maximized individual soldier firepower. The M1 Garand's influence extended far beyond American doctrine. Nations worldwide studied its design, manufacturing methods, and tactical employment. The rifle became a blueprint for post-war small arms development across ideological boundaries. The Soviet SKS carbine, adopted in 1945, incorporated semi-automatic gas operation and magazine feeding clearly influenced by M1 principles, even as Soviet designers pursued their own engineering solutions. The German Bundeswehr's G3 rifle, adopted in the 1950s, reflected lessons learned from facing M1-equipped forces, that modern infantry required self-loading weapons as standard equipment. Even the AK-47, perhaps the most influential military rifle ever designed, embodied the battlefield philosophy the M1 Garand proved. That distributed, reliable, rapid-fire capability in the hands of every soldier determined infantry combat outcomes more than precision marksmanship or elite training. Mikhail Kalashnikov himself acknowledged studying various semi-automatic and automatic rifle designs when developing the AK-47. While the AK-47's mechanism differed significantly from the M1's, the underlying concept remained identical. Give every infantryman a weapon capable of sustained rapid fire without manual cycling. The M1 Garand served as the U.S. military's standard rifle through the Korean War, where it again proved superior to bolt-action weapons, and continued in service until replaced by the M14 in 1959. Total production exceeded 6 million rifles. Surplus M1s armed Allied nations for decades, serving in conflicts from Vietnam to the Middle East well into the 1970s. But the M1's true legacy wasn't measured in production numbers or service life. It was measured in the complete transformation of infantry doctrine it forced upon the world's militaries. By 1960, no major military force issued bolt-action rifles as standard infantry weapons. The transition to semi-automatic and automatic rifles became universal. The M1 Garand had demonstrated an irrefutable truth. In modern combat, fire rate and sustained fire capability determined outcomes at the infantry level. General George S. Patton's assessment proved prophetic. The M1 Garand was indeed the greatest battle implement ever devised, not merely because of its mechanical excellence or manufacturing quality, but because it fundamentally redefined what an infantryman could accomplish on the battlefield. The German soldier of 1944, carrying the same rifle his father had carried in 1918, represented the end of an era. The American soldier of 1944, carrying the M1 Garand, represented the beginning of modern infantry warfare. The M1 didn't just outperform the K-92, it rendered bolt-action dominance obsolete and established the template every military rifle would follow for the next 80 years. In doing so, it proved that industrial democracy, American workers producing precision weapons at unprecedented scale, could decisively defeat martial tradition, elite training, and battlefield experience. The future belonged not to craftsmen hand-fitting rifles, but to factories mass-producing interchangeable excellence. The M1 Garand was the weapon that proved it.